Hello and welcome to today's lesson. Today we're talking about adding and subtracting rational expressions. So we've already gone through how to simplify them, how to multiply and divide them, and now we get up to the adding and subtracting. And if you remember from your work with just normal rational numbers or fractions, you may recall that adding is a lot more complicated than multiplying and dividing. So before we get into our expressions, let's start first with rational numbers or just regular fractions and remember how to add them. Okay, so it's necessary to first find a common denominator. So to do that, you look at the two denominators, in this case 2 and 4, and you say, what's a number that I can multiply both of these two, so the lowest common multiple, so that way I can add them. Because fractions just show parts of a whole. So you need to make sure that you're representing the whole as having the same amount of parts. Okay, so in this case, the lowest common denominator would be 4, between 2 and 4. So you write both of the fractions with that denominator. Okay, so 3/4 stays the same. But now 1/2 has to be written as the same fraction with a denominator of 4. So to get from 2 to 4, I multiplied 2 by 2. And so I have to do the same thing to the numerator. 1 times 2 is 2. So 2/4 is the same thing as 1/2. So now that they have the same denominator, you can just add the numerators and you leave the denominator the same because that represents how many parts are in a whole. So this is 2 out of 4 parts plus 3 out of 4 parts gives you 5 out of 4 parts, okay? Now in this case, 5 and 8, when you're unsure of a common denominator, you can always just multiply them together and get a common denominator. It might not always be the lowest. So for instance, if I had done 2 and 4 to get me 8, it would have still worked. It just wouldn't have been the lowest common denominator, just a common denominator. But in this case, the lowest common denominator is 40. Okay, so I rewrite them both with a denominator of 40. Now to get from 5 to 40, I multiplied by 8. So 2 times 8 is 16. And 8 to 40, I multiplied by 5. So 3 times 5 is 15. So 16 minus 15 is 1/40. Okay? Now in this case, I could, with the 6 and the 4, I could multiply those together to get a common denominator of 24. And I would get it right. I would just have to reduce it at the end. But the lowest common denominator in this case would be 12, because 6 is multiplied by 2 to get to 12, and 4 can be multiplied by 3 to get to 12. So the lowest common denominator is 12. So you write both with a denominator of 12. 6 is multiplied by 2, so you get 2. 4 with 3 times 3 is 9, so you get 11/12. All right, so if that's what we do with numbers, then it will be the same concept with expressions, just obviously quite a bit of added difficulty because of the variables. So the same rules apply. So one way to be sure of a common denominator is to multiply all of the factors together, just like I set up here. It may not be the lowest, but it will be for sure a common denominator. So a common denominator of 1/x plus 5 and 2/x plus 3 would just be x plus 5 times x plus 3. You don't need to expand it or anything, you just leave it like it is. You just multiply the two denominators together. You can rewrite fractions with the common denominator by multiplying the numerators and the denominators by the needed factor. So to get from 1/x plus 5 to our new expression, remember your new denominator is x plus 5 times x plus 3. So again, you just think about it the same way. To get from x plus 5 to x plus 5 times x plus 3, I multiplied the bottom by x plus 3. So that means I need to multiply the numerator by x plus 3 as well. So 1 times x plus 3 is just x plus 3. So there you go. Now 2/x plus 3, again, you want to rewrite it with x plus 5 and x plus 3 as the denominator. So I would need to multiply the numerator by x plus 5. Okay, now this can be expanded to 2x plus 10 over x plus 5, x plus 3, but you may not always need to do that. Okay? So at this point, it's important that you understand how to get a common denominator. Okay, we're going to do some examples with expressions. Because once you understand that, then the adding and subtracting will become a lot easier. So first we want to find the lowest common denominator of all of these, and then we want to rewrite each of these expressions with that common denominator. So we're not actually doing any adding or subtracting here, just kind of the prep work for adding and subtracting. So here we have an x squared, and a 5. So most of these common denominators will have number components and variable components. So in this case, this would be a 1, and a 5. So the lowest common denominator of the numbers is 5. And of the terms, it's x squared. Okay? Because the highest term has an x squared. So that means that they all would have to multiply to an x squared. Okay, so the lowest common denominator is 5x squared. So we're going to rewrite all three terms with 5x squared as the denominator. So I like to set them up like this so I can think about it that way. So you have to think, what did I do to x to get it to become 5x squared? Well, I had to multiply it by 5x. So that means this 3 needs to be multiplied by 5x as well. So 3 times 5x is just 15x. Okay? Now you'll know you got this right if you, in your head, you can reduce this, and when you reduce it, you should get back to your 3 over x. Okay, again, to get from the x squared to the 5x squared, I simply multiplied it by 5. So then I need to multiply my numerator by 5. So 5 bracket x plus 1. Okay, or 5x plus 5 you could have written. Now it's important that you don't all of a sudden just write 5x plus 1 without the brackets. Okay, you have to show that the entire numerator is being multiplied by that 5. Okay, and to get from 5 to 5x squared, I multiplied it by x squared. So again, my numerator must also be multiplied by x squared. Okay, so number 2, here we go. So first, you look at the numbers. So 3, 4, and 1 have a lowest common multiple of 12. Okay, then x and x cubed, the lowest we can go is x cubed. Okay, so that's our lowest common denominator, so we write all three terms with that denominator. Okay, so this was multiplied by 4x squared, so we multiply the top by 4x squared. Okay, from here to here was multiplied by 3x squared, so we multiply the top by 3x squared times x minus 3. Okay, it's crucial, again, that you use brackets here. I mean, you can put brackets around this too if you'd like, to show that all of that x plus 3 is multiplied by the 3x squared. Okay, without that, you would be making a big error. And then here, this was multiplied by 12, so this just becomes a 12. Again, to make sure that you did this properly, just reduce the fractions and make sure you get back to the original ones. Okay? I encourage you, you can pause and try these next ones on your own, but they're a little bit more complicated because now we're getting into binomials. Okay? So this one, you can't just look at the numbers and then the variables because they're actually being added together. Here, these are two similar types because all of the denominators are monomials, okay, only one term in the denominator. But here we have binomials, so we have terms being added and subtracted together. So in order for us to find the lowest common denominator, we have to think about x plus 1, you know, as a unit. So in this case, you could do x plus 1 times x plus 4, and then times another x plus 1, but you don't need to because there's already an x plus 1 included. Okay, so our lowest common denominator is actually x plus 1 times x plus 4. You don't need to include a second x plus 1. Just like if you had a half, a third, over 2. Okay, your lowest common denominator is just 6. You don't have to do 2 times 3 and then times another 2. Okay, so let's get ready by setting up our 3 fractions with the denominator x plus 1, x plus 4. So just set up your 3 fractions that way. All right, there you go. Okay, so to get from x plus 1 to x plus 1 times x plus 4, I had to multiply it by x plus 4. So you get 2 bracket x plus 4. Okay? From here to here, I had to do it by x plus 1. So I get x times x plus 1. And from here to here, I had to multiply it by x plus 4. So you get x squared times x plus 4. And you're done. Oh, again, to check if you're right, just cross off and make sure you get back to the original. Okay, this last one is the most difficult because we have each fraction, each rational expression has 2 binomials. So you just need to make sure that all of these denominators are included, okay? So we start with x minus 3 and x plus 5. Okay, so that denominator is included. Then we have another x plus 3. Oh, I already have one of those. And an x plus 1. So I got to add an x plus 1. Okay, we're good. And then an x plus 1, I already have one of those. And an x minus 4. So I got to add that. So I'm not going to lie, this is a pretty gross denominator. Okay, it has 4 binomials in it. Okay, so obviously don't expand it. You just leave it the way it is. Now I should warn you, if all of a sudden one of these, let's say we had 3 over x plus 1, x plus 1, you couldn't say, oh, I already have an x plus 1, so I don't need to do another x plus 1. Because this fraction would have 2x plus 1s, just one of those fractions, so that would mean the common denominator has to have 2x plus 1s in it as well. Okay, so just be careful for that. Okay. So we have our 3 fractions, all with this humongous denominator, okay? So I'm just going to say, that's the gross denominator, okay? So to get to this gross denominator for the first one, these 2 are already included, but I have to multiply the numerator by these guys. So I just get 1 times x plus 1, x minus 4. Okay, now for this one, I have an x minus 3 and an x plus 1. So the x has to get multiplied by an x plus 5 and an x minus 4. Okay, here I already have an x plus 1 and an x minus 4. So this 4 needs to get multiplied by an x minus 3 and an x plus 5. And there you have it. Okay, so take some time to look that over, because now we're going to get into the actual adding and subtracting of these rational expressions. Okay, so the first skill you have to master is being able to find that common denominator, okay, which is tricky, obviously. So make sure you rewatch that as much as you need to understand it, because it's a crucial skill in order to do the rest of this work. Okay. So now we're going to actually simplify this by adding and subtracting this fraction. So we have this plus this minus this. So just as in any rational number, first you need to find a lowest common denominator. So notice that I've actually written out the steps here for you. So make sure you have this with you tomorrow when you're doing the work in class to make sure you're actually following each of these steps, step by step. Okay? So first we find the lowest common denominator. Again, these are all just monomials, so we're just looking at the numbers first and then the letters. So amongst 8, 4, and 6, the lowest common denominator there is 24. And amongst x squared, x, and x cubed, we need an x cubed. Okay? So now we want to rewrite the expressions with the lowest common denominator as the denominator for each. So something over 24x cubed plus our new fraction over 24x cubed minus this other part over 24x cubed. All right, so to do 8 here, we need to multiply it by 3x. Okay, so it becomes 3 times 3x. Okay, from here to here, it's 6x squared, so 1 times 6x squared. And from here to here, it is 4, just 4, so 5 times 4. Okay, so now you can actually rewrite this as just one fraction. Okay, because they all share the same denominator, you can actually rewrite it as one fraction with this denominator of 24x cubed. Okay, so you get 9x plus 6x squared minus 20. Okay? And we like to just put this in a better form, put the 6x squared first. Over 24x cubed.